Now let's talk about how to use the Smith chart to find the transmission coefficient. The transmission coefficient is 1 plus the reflection coefficient. The transmission coefficient tells us how much voltage is transmitted divided by how much voltage was incident, on a load for instance. The transmission coefficient can be found using a different set of axes. So instead of using the axis that said angle of reflection coefficient, I'm going to use this axis that says angle of the transmission coefficient in degrees. Let's see how it goes around like this. It's the innermost line of the Smith chart axes out here. So that's where I'm going to find the angle of the transmission coefficient, and then I'm going to find right here this line that tells me the transmission coefficient for E or I. That's the same thing as the transmission coefficient for the voltage. Now let's suppose, for instance, that I had a reflection coefficient here at 45 degrees. Let's find our transmission coefficient 45 degrees. Sorry, our reflection coefficient of 45 degrees. That's the angle of the reflection coefficient. Let's draw our straight line from the center of the Smith chart out to that point like this. And then let's just choose a point right here. That's my reflection coefficient. I can also find the transmission coefficient from that same point, and what I do is I read off the angle of the transmission coefficient. So you can see here it is 10, 15, 20, 25. Looks like the angle of the transmission coefficient is about 22.5 degrees in this example. Let's find its magnitude. We do that the same way that we found the magnitude of the reflection coefficient, except that instead of using the reflection coefficient, we use the transmission coefficient axis. So take your piece of paper, mark this distance right here from the center to the point that you're interested in, bring it down to the Smith chart and line it up again with the center. We always start at the center and then draw a line right down here. Looks like the magnitude of the transmission coefficient is about 1.55. Now again, let me emphasize that this center point right here is always where we're going to start. We're always going to line up this point right here with this point right here, whatever measurement that we're doing. Now what if I wanted to find the transmission coefficient for power? Look, there's another axis right here that will give me the transmission coefficient for power. Its magnitude is 0.7. Its phase is the same as you see up here at the top, 22.5 degrees. There also is a reflection coefficient for power right there, and we can use that for measurement as well.